Thanks, guys. So it's a pleasure to be here. I'm trying to make it a bit funny. I don't want to get. I know that you are tired, probably, me as well. The whole day was rich of nice talks. So this is the last one. So the last effort, and then we are done. So this talk is about the privacy and the security risk of a cloud computing services. And just briefly about myself. So I'm Italian, as you can understand from my accent. And then I moved to France. I worked there for 5 years. And I spent the last 3 years doing research in a research lab in South France. And previously, I was working for different companies doing penetration testing, vulnerability assessment, so any kind of security consultancy service. And recently, I joined Trend Micro, where I am a senior threat researcher. OK, so this is the roadmap for today. So I will start introducing a bit rapidly what is cloud computing, but I think you are pretty much expert on this. In particular, we will focus on one special service offered by cloud computing, which is called IaaS. And we will look at Amazon EC2, that is probably the most famous service provider of this type. Then we will define what is the problem, and we introduce a tool that we develop to automatically analyze the Amazon EC2 service and to study the different problematics related to the use of this service. We'll then conclude with some lesson that we want to bring on, and that's all. OK, so what is cloud computing? If we look at Wikipedia, Wikipedia says that it's the delivery of computing as a service rather than a product. What does it mean? It means that using a network, that usually is the internet, you can get access to different services, such as application. For example, Google Mail is an application that runs over the internet. Platform, for example, platform for developing software or databases, or even infrastructures. That means that you can rent over the internet, like storage or computation. So as you can see, cloud is somehow an old and new concept. In fact, it's been around since many years. So parallel, distributed, and grid computing have been used from a while by scientists, government, and different organizations, for example, for doing urban planning, weather forecast, modeling of economic. So there is nothing new there. So what is cloud computing? Why nowadays everybody is talking of cloud computing? Because cloud computing is a commodity. So who does not use cloud nowadays? Just take, for example, as I was saying, a Google Mail. That's a cloud service. So I mean, I guess most of us probably are using Google Mail. So why? Because it's easy to use. In fact, the cloud is a kind of ready-to-go service. You go over the internet, you choose your service, you pay if you have to pay, you click, and you're ready to go. So you have a mail set up for you. You have, for example, if you think at Dropbox, you have some storage somewhere ready to be used. Or if we look, what we will look here, Amazon, you can easily buy a server over the cloud in a couple of clicks. So there are three main models of cloud service. One is called software as a service. The other one is called the platform as a service. And the first one is called infrastructure as a service. So in the first one, what is provided by the cloud is a software, like a CRM. For example, Salesforce provides a CRM over the cloud. So it's SAP as well is providing now is software over the cloud. And the cloud can provide also other software, like email, games, and so on. Then there is another model that is called platform as a service, where what is provided by the cloud is either computing or a solution for development. For example, Microsoft Azure or Google App Engine. And the third model, which is a model we will try to look at, it's called infrastructure as service. So what is provided by the service provider is either some computers, for example, physical or virtual, or even storage, firewall, or even networks. So in this IaaS service, the leader is Amazon with this service that is called Elastic Compute Cloud. Okay, the acronym is AC2. And so this is the main player there. There are then a lot of other competitors. For example, famous names are Rackspace, Terramark, Giant. So they pretty much do the same things. Probably some of them probably are cheaper, and this is because probably the network, the amount of capabilities that they can offer is a bit less. So what all these service providers offer is the access to a virtualized server image. And how can you pay? You pay usually on an hourly or monthly basis. So we'll see this one in detail. So let's look at Amazon AC2. So in Amazon AC2, user can rent what is called an Amazon machine image. Okay, this Amazon machine image, usually it's a machine that is either Windows or Linux, and is usually configured with standard software. Classic example, you want to set up, for example, your internet site. So you can go there, look up for a machine that has some specific configuration, some specific web app. You just choose the machine, you select, you pay, you put your credit card, you say, OK, run, boom. And then you can run it for an hour, a week, or a full year, and you get charged every month for the amount that you use this image. At the same time, what is interesting in this model is that the user itself can publish an image to the cloud. Okay? So there are three different types of users. The first one is Amazon itself. So Amazon provides the infrastructures, but also provides some image. Okay? Then there are individuals. So for example, me, I can deliberately set up an image and upload it to the cloud. And I can say, OK, this is public. Everybody can use this image. Okay? And then there are third-party companies that actually run a business on this model. So they pre-configured some image, and then they put the image over the cloud, and they ask Amazon to charge extra cost. So in this way, when a user rents an image of a third type, he has to pay twice. He pays for Amazon for the infrastructure, for the processing capabilities, and this third-party company for having provided the image. So how an MI can be built? There are three ways to build an MI. First, it's from a live system. So you have your operating system like this. OK, this is a Mac, so it does not work. Suppose I have Windows here. There is a tool I can run from command line. It will do like a snapshot of the live system. It will put it in a ISO, and then I can upload the ISO on the cloud. You can build an MI from a virtual machine image that you have ready, or you can clone it from another MI. So I can take one that is already running, it is available on the cloud, I can take it, clone it, and re-upload it over the cloud. Then, how can I start an image? Okay, so Amazon provides either an API that you can use to start image from command line or from scripting, or you can do it using the web app. In any case, you have to specify the credential that you will use to log into the MI. Usually, for Linux, is a public SSH key. Okay, so you have to say, okay, this is my key. Start this image with this key. So what Amazon does is run the image and then upload your key to the image, so that only yourself can access to the image. Then you have to specify the different resources you want, like how much memory, the different processor, the I/O performance, and so on. In which region you want the image to start. For example, if my business is in Europe, it makes sense to put the image in Europe. Instead, if your business, for example, worldwide, and you want to load balance the load, you can start the image, I don't know, one in US, one in Europe, one in Asia, and so on. Okay, finally, when you have configured your image and you start the image, you can reach, Amazon will give you an host name that is on this form. So AC2 minus IP minus the different region, like Asia, .computer.amazonavs.com. And it will be accessible via SSH or remote desktop if you are under Windows. OK, what is important to say here is that Amazon does not care about securing the image. What does it mean? It means that the user is completely responsible to maintain the server. So that means that the user has always a root privilege because he needs to administer this system. So this is a key point, and we will get back to this later on. Here are a couple of screenshots on the Amazon management console. For example, you see on the corner, up left here, you can choose the region where you want the image to start, like Ireland. Here you have a key pair, so that means my SSH key that I want to use to authenticate to the image. Then I can click here, launch. When I click here, this pop-up come up. So there is ever a quick start where there are some predefined image. For example, the first one is an image provided by Amazon itself because it has an Amazon logo and is marked as favorite. And the other one is, this is a Red Hat, this is an Ubuntu, so you can choose if you want 64 or 32 and you start. That are the images that are mine, so are marked as private, so nobody else can run except me. And these are the community MI, that are the most interesting one, are the MI that are there to be used by everybody. So when I choose the image that I start, the image gets loaded, and when it's running, here it tells you which kind of zone has been run, and that's the public DNS where you can reach the image. There is also a private IP address, so every image has two interfaces, one on the public IP, one on the private network of Amazon. OK, so that's the first part, just a brief introduction. Is it clear? Do you have maybe a question before I go on the cool part? OK, so a popular approach here in this Amazon EC2 is the possibility to create, publish, and share server images with our users. So if the trust model between cloud provider and user is well defined, in the sense that Amazon is not going to hurt you, what is not clear is was the model between the image provider and the user. In fact, the user can create and share images as well. So the whole question of our research is this one. Are there any threats associated with renting images from public catalog of cloud computing providers? And if there are threats, to which extent? So in particular, we look at three different problems. The first one is concerning securing the image against external attacks. So suppose you rent an image and you want to make sure that no other people can access your image. The first one is securing the image against malicious image provider, because if you start an image and you don't know who has created this image, I want to make sure that the provider, that is the guy that uploaded the image, is not malicious, so has not put this image there on purpose for you to use them. And the third one is about sanitizing the image to protect the privacy of a provider. So what we did, we developed an automated system for the security analysis and measurement of these three problems. And we test over a period of 7 months all the public server images provided by Amazon in its 4 data centers. Okay? So US, East Coast, West Coast, Europe, and Asia. And we successfully scanned more than 5,000 machines in an automated way. So how we did it? We did it with a tool that I call SatanCloud. So it's cloud because it works on the cloud, Satan because it's an evil tool, and because it sounds a bit like Santa Cloud. The tool is composed of 3 main components. So you have a robot that instantiates an MI check that is correctly running. retrieve check with credential, and give OK. So then when the MI has been instantiated, it passes the control to two scanners. One is a remote scanner that scans the machine from the remote point of view, from a network. The other one is a local scanner. So the local scanner authenticates to the machine and execute some tests from the inside. So these two scanners are somehow complementary. They complement each other. So the simple one is a remote scanner. This is just a simple component. So we use Nmap to collect information over the network. So we scan the IP address of associated to the instance to collect the list of open ports, the fact that if there is a web server, if there is a web application running, the different web modules, the different service, open ports. We will see the utility of this later on. Just remember that this is one thing we do when we scan the image. Let's now look at the local scanner. This is the main component. So the local scanner analyzes the MI for known vulnerabilities using the Nessus tool. And at the same time, when we scan the image for known vulnerabilities, we also upload to the MI what we call a test suite. So a test suite is a self-extracting archive, okay, that contains 24 tests that are grouped in 4 main categories. Okay. The first one is a general category. So it tests the system for system information, log files. It collects different data, like the var log or like sensitive data. Then there is another component that is, probably you will see here. Can you read it? Yeah, I guess so. So on the top, you have the first one are the general test, so that collect information on the machine. The second one collect information about, for example, if there are some shares open on the machine, if a machine is connecting to some external server. So suppose you have a machine that is infected by malware, okay? This one, for file left by the provider, because we are saying that everybody can publish an image. So we check if the guy that published the image maybe left something like history files, private keys, and so on. Credential for SQL database, password. And finally, we have some tests related to the security. So we test if the machine contains some rootkit, some malware, or some hidden process, and so on. Good. So what are the findings here? So the first finding is related to software vulnerabilities. Why we test that? We test that because the model, the business here is, okay, you can rent an image over the cloud, you can rent a server. No need to have a server at your home. No need to buy hardware dedicated to your server. No need to invest time in configuring your own machine. Come to us. You can buy the server there. It's easy, You just select the image, you click, and you go. Okay, so let's see if the image that I rent there are up to date or not. So using Nessus, we just enable Nessus to test only the critical vulnerabilities. So Nessus has a level from 0 to 3. 3 are the critical vulnerability. That means that if you have a critical vulnerability, usually your system can get compromised remotely. And we configure Nessus to check the vulnerability locally on the machine to be more precise. So the two plots, the first one is Windows. So on the left is Windows. On the right is, the left is Windows, on the right is Linux. So as you can see in Windows, there are really a lot of vulnerabilities, really a lot of MIs, more than 15 or 20, that have like 50 critical vulnerabilities. And Windows is like Linux is like the better, but still there are hundreds and hundreds of machines that has at least 5 or 10 critical vulnerabilities. So these are the data. So in average, a Windows machine comes with 46 critical vulnerabilities, and Linux with 11 possibly exploited software. And in fact, if you look, 98% of Windows and 58% of Linux MI come with critical vulnerabilities. That's really a lot. So second, there are a lot of vulnerabilities that are more than 2 or even 3 years old. That means that on the Amazon network, there are images that come with software that is very obsolete. We also found 87 MI, Debian MI, that come with a notorious SSH OpenSSL vulnerability discovered in May 2008, where the famous vulnerability where the key was not generated randomly, so it was possible to brute force the SSH key and get access to the systems. So the message here is clear. You have to, if you use an image or a cloud, you want to make sure that you patch it, you update it, and you have to invest time in that, and you have to be able to do it. So it's not point and click. We then look at malware. So we also scan using Clamavis, so a free open source antivirus contains 850,000 signatures, all the MIs, and we discover 2 machines containing one spy Trojan that was doing key logging, process monitor, and data leakage, and the other one was a browser spyware installed in Internet Explorer. So the first one has been confirmed. That means that when I did the test, like 2 weeks later, I checked. I saw, oh, wow, one of these images has a problem. So I started the image again, and I found that there was this Trojan installed. So probably a guy explicitly installed a Trojan in the machine, put the machine over the cloud, and wait that somebody is using it. Instead, the second one has not been confirmed manually. So either it's a false positive of Clamavi, or the machine got infected during our experiment. In fact, every machine is run for 1 hour without having a firewall. And it can be that if a machine it has a lot of vulnerabilities, it can be that in this 1 hour it can get compromised by a Trojan. When we look at the possibility that some machines were connecting outside, sending, for example, out sensitive and private information. So we found 2 Linux servers that were using Syslog ng to send the log to a remote host. That means that you rent a machine, you use it, and all your log will be sent outside. This one will be sent to, they were sent to a Russian server that was collecting logs from this machine. Good. This is an interesting point, is the fact that when a user rents an MI, as I was telling before, he has to provide his public key to get access to the MI later on. So what is the risk here? The risk is that users could leave the key behind and make the image and mark the image as public. What does it mean? It means that this key, if you don't delete, if this key is still present on the image, then the guy that has a private key can then connect to your image. So this key turns the image into backdoor, basically. So you have the same problem if the image comes with some password that have been left enabled, or some user that have been left enabled. So here you have we did the experiment on the 4 region, and it came out that 1 machine out of 5 come with leftover credential. This can be either password, enable password, and enable user with a shell, or can be SSH keys. This will allow to the user that has either a private key or know the the username and password to access to your machine. So you rent a server, and then somebody else is connecting to your server. And in more than 900 cases, this allows a super user privilege. So leftover credential is a security risk. At the same time, is a privacy risk. Why? Because if you can see here, we found 101 machine with leftover password. So what I can do, I have this password, you know. I can brute force them, okay. I can then look in last log and see who is the guy that uploaded the machine, and then I can try to reuse the same password and get access to their machine. So this will bring us to the privacy risk related to the use of a service like Amazon EC2. So what's the problem? The problem is that if the image contains sensitive information, this would be available to anybody who is renting the MI. Okay, that makes sense, no? So not only customers have potential risk, but also the provider themselves. So we can use this credential, for example, to log into our server or to start instance over the cloud for free. So this is what we look here. So we look at forgotten keys. So we search among all the image for SSH keys and for Amazon API keys. So we find out that the machine over the cloud, they were containing 56 private SSH keys. Interestingly, 54 out of 56, they were not even protected by a passphrase. Okay, so it's easy, you know. I take the IP log from the log from var log, and then I have a private key, and then I also collect 67 unprotected Amazon keys. These are great because when you have one of these keys, you can you can buy something over the Amazon cloud. So I can buy 2 terabytes of data. I can buy 100 images with a 64-core processor, and the poor guy is paying for me. And these are not protected by password. Still, this one is like that. So probably Amazon, they should add a feature where you can at least protect your Amazon API key with a password. Other things we look at our shell history, okay? So all the shell in Linux, like Bash, C shell, they record everything in a file, no? So it makes sense to delete this file before you upload your image to the cloud. Otherwise, if somebody else rent this image, you can get access to your shell, no? And in fact, we solve a problem. So we find 869 files that were storing interesting information for a total of 150,000 lines of command history. So I wrote a parser to parse all of them. And I found interesting things. For example, look at this, MySQL, you know? You know that you can use MySQL from command line. You can specify username and password. So you can say MySQL minus U, Marco, minus P, Pippo, host name. What's the problem there? It's the same problem that you have on a web application when you transmit sensitive information using a GET instead of a POST. If you send username and password using a GET, the GET will record it in the log of Apache, for example. Here is the same. So if I crawl, I can crawl username and password. So I extract 58 credentials, and 30 of them are for a remote machine. So local means the MI itself. Remote is a remote machine. So I had the username and password for 13 remote machine, for 4 Amazon RDS service, for 1 dynamic DNS portal. So I can configure the dynamic DNS, for VNC, and so on. So the next question is, OK, there are all this sensitive information left by the providers. So what the providers should do? Should they delete their data before putting the image on the cloud? Yeah, maybe yes. So let's look at this. So we said the MI can be bundled using different methods. So there are, if in details, 4 different methods. One work at file system, okay? So that means that is just a bare copy of data, okay? Like just a copy. While 3 of them work at block level. For example, under Linux, DD work at block level. So you can say, this is my machine, okay? Take this machine, put it on an ISO, and then upload the ISO over the cloud. Usually this process is, it works at block level. So all the block of my machine, that one that are free and that one that are occupied by data, they got into the ISO and they get uploaded. So problem is that the block-based bundling method are vulnerable to file undelete attack. So do you remember the time when there was the DOS and you were deleting a file because there was no trash can? So you were doing del, the time was del, name of a file, enter, and say, I delete my file. Okay, what I do? Yeah, there is a tool to recover the file. You know, if a file is not overwritten, you can recover it. Here is the same. So the publisher, what they do, they clean up the data before publishing the image, but they don't wipe the free space. So what we did, we select, how many? We select 1,100 Linux MIs randomly. We run this Undelete tool to recover data. And we undelete 28 gigabytes of data. So we recover a file for 98% of MIs. So each MI contains average from 6 to 40,000 files per MI. So there are different files. For example, there are 33,000 files in the home and in the root directory containing images, Microsoft Office document, Word, Excel, so on. Amazon AVS certificate and access key. This one I showed you before. This one, 67, have been left. They forgot even to delete it. This one instead have been, the 293 have been deleted, but we recover them. Then we have SSH private keys, even one from an official Amazon image. So 100%, this is a key of one of a guy working in Amazon that set up the machine. Then we have private keys for PGP, GPG, PDF documents, password files, and so on. That's a screenshot for a recover process under Windows. For example, here I was in RDP over one of the images that I rent. You can see here the IP. This is AC2. That's the IP of the machine, 46.under37, 40, blah, blah. Rented in EU West, so Ireland. It's very easy, no? You install a win and delete tool. You just recover, and you recover about 9,000 files. Okay, so we are almost done. So you have seen that these Amazon images, they have both security problems and both privacy problem. So let's look at the security problem. So you know that, for example, 1 out of 5 of these images, they come with some enable account or with some SSH public key installed. So suppose that now the attacker wants to locate this image, okay? So me, for example, I set up an image, I add some credential, okay, or some keys, I upload it, and then I wait. So I wait that somebody is using it. So ever there is ever install like a client or something that when the image start, ping me back and give me the IP on which the image is running, so I know that it's 111 and then I can connect to 111. Or, how can I do? What I can do, I can I try to match all the IPs on the address space of Amazon to my catalog of 5,000 machines. How can I do it? I can do it using a perfect solution, or pretty much a perfect solution that is based on SSH host key comparison, matching, or I can use approximate solution like service banner and web banner. What does it mean? it means that what we did, we scanned all the Amazon IP range, okay? So that are about 650,000 IPs. And out of these 600, there are 233,000 running instances. So out of all the Amazon IP space they have, they're using about 1/3 of it, okay, at the time. So of these 233,000 instances that are running, there are 130, so about 50%, that have SSH enabled, okay? So they are Linux machine, and they have this service not filtered. So for this one, we can use the SSH method. So what does it mean? We using Nmap, the Nmap we saw before, at the beginning of the talk, we collect the fingerprint of SSH, and then we match this fingerprint with the fingerprint of a different 5,000 machine that we scanned. And we had a perfect match, one-to-one, for 1.65% of this number. That is about, 20,000 machine? No, 2,000 machine. So for 2,000 machines, or for 2,000 IPs, we have a perfect match. So I really know which kind of Amazon MI is running. And if I know that if this Amazon MI is running has some backdoor installed, I can log in if I have a credential. Then, of course, if you look at a set of 10 candidates, we have a percentage that is wider. If you look at a set of 50 different MIs, it's wider. Still, is 10 candidates, you can easily, if you know that one IP can be one of these 10 MI, you can easily test all of 10. So it's not a big issue. The other two matching system we have, one is based on service. So we look at the list of open ports, the service that is running and the version, and we make sure that it's the same of one of the MI that we have in the catalog. And the last one is based on the web app that is installed. So we look at different type of web app, different type of web server, and we try to match the IPs with MI based on this information. Okay, so I want to say that during our experiment, we were always in contact with the Amazon security team that did a great job. So when I do my research, sometimes I don't have feedback from the different providers or from vendors. Instead, Amazon did a great job. So when we contact them about the password and public keys that we found on this 20% of images that are 1,200. So I give them the list of 1,200 MIs containing some forgotten credential. So what they did, they immediately contacted all the clients saying, hey guys, the image you are running contains some credential, so make sure you remove it, otherwise you have a backdoor. And then they released the public bulletin the day after, and they changed the status of a vulnerable MI from public to private, so that no more user can rent this MI. Then I contact them a second time about the leftover data, so the fact that there are a lot of images where the guy that published the image forgot to delete their data, like the history files, so there are a lot of credentials, or there are some private SSH keys or Amazon API keys. So they released within 5 days a tutorial to help customers to share the public images in a secure manner. Like, hey, do you want to share your public image? Okay, maybe delete your credential or your sensitive data. First things, I contact them again about the problem of recovering deleted data, where you can undelete deleted files. So they verified our findings immediately, and they are now examining all the different MIs to see what's the problem there, and if it makes sense to change the bundling system to make sure that it's not possible to undelete data from the hard disk. Good, so what we learned here, we learned that if we want to use the cloud, the best way is to prepare your own image. I know it takes time, you know. You have to install the image, you have to configure it, but then it's yours, you know. I mean, if you want to really run an image over the cloud for a long time, don't trust one of the images that are there. Just spend maybe 1 day to configure your own image, and you are done. Because if you buy an image that is there, then Who tell you that the configuration file of Tomcat is okay? Who tell you that all the software is patched correctly? Who tell you that there are no problems? So still, if you want to use one of these images, you have immediately update the software. Otherwise, especially if it's a Windows machine, because a Windows machine with no firewall on a public IP with 50 critical vulnerability get exploited in 10 minutes. You have to regenerate the SSH host keys to prevent a mapping between a running instance and MI. You have to delete any user, password, and SSH keys. Check the configuration file of service you plan to run. Check for suspicious connection. So you have to do all of this. So if you plan to release a public image, then use a file-based bundling mechanism so that nobody else can recover your data, the data that you deleted. Or shred any sensitive files. And finally, delete any logs and history files before putting the image online. So here are just two references. You can then download the slides, so no hurry to copy them. So these are the two. So when we contact Amazon, they wrote two posts on this problem. First one is how to share and use public MI in a secure manner. The second one is a reminder about safely sharing and using public MI. So this is a co-joint work among me and Jonas Zadak, Davide Balzarotti, and Engin Kirda and Sergio. I worked with them in Eurocom last year. And we also published a paper on this topic in the proceeding of a conference a couple of months ago. So in the paper that you have there are actually all the study we did, and it's like 10 pages of details on the problem. So maybe if you're interested, it's worth to read it. Okay, that's all. I was pretty fast. So you have time for question, for coffee, to recover before the final keynote.
I think we can go for some questions if you're up for it. So
yeah.
Does anyone have any questions for Marco?
When was that notice about public keys in AMIs? That was quite some time ago, wasn't it?
The first problem about the public key, I think it was in September, October last year.
Yeah, I wondered why all of a sudden they started looking at that one. So I did get the notice from Amazon. So
okay,
now I know why.
Okay,
thank you. There is good reasons to have, I deploy training machines in the cloud, and there is a good reason to have a public key on there so that students can actually log into those machines.
Sure.
And they want to share them. So it's, in this case, that use is sort of nullified.
Oh, that makes sense. I mean, if you have an image, you want many people use this image, you have to put something there and leave it there. That's, of course.
The sophistication of a lot of the AMIs that people create, sort of the homebrew, as you know, are often very heterogeneous. How did your research find sort of the optimized, the official ones? So Microsoft's optimized image, Amazon's optimized image, and so forth.
I didn't understand you. How my research?
In other words, I think for many of us, we are rightly afraid of other people's, home-created public AMIs for all these reasons. But how about Amazon's image? How about Microsoft's optimized image? As you know, there's probably 5 or 6 that are put out not in sort of the marketplace, by third parties, but by the primary, vendors or package distribution folks.
Okay, so you're asking me, on the marketplace, there are images provided by Amazon itself, by individuals, or by third parties. So you're asking me if there is a difference among the different ones, if there are some that are more vulnerable to ours?
I sure hope you're going to tell me that Amazon and Microsoft's optimized hardened images did much better.
Yeah, we didn't make a difference because we didn't want to say Amazon is good, instead provider Microsoft is bad or provider C is good. You know, we try to look impartially to all of them. But there is actually, it makes sense that image provided by, that are officially provided are probably more secure than others. So I know that there is a site that it's called Cloud Market, like, I don't remember, but where actually the user can say, okay, I try this image and it's okay. Or they can give some stars, so there are a mark. They can give a vote from 1 to 5. So they can say 5, this is a good one. It's like Google for the restaurant, you know. You want to go to a restaurant, you check there and say, you know, a lot of people say this restaurant is good. So we have something similar for the cloud market of Amazon. So I suggest to use this site, to just Google on the internet, like cloud market Amazon ranking. And you can, before using an image, you can check there what the people say. If nobody say nothing, maybe you better use another one. Yeah.
Okay. Sorry.
You said you contacted the security team of Amazon, and did you had an indication that they detected you before because you rented the machines and started scanning them, so it looked like suspicious activity?
So you are asking if when I contact them, they knew that we are already testing them? No. Actually, the good things that I was working with research lab, and we have a possibility to do our experiment without asking before. Like we start, we did the test, we scanned the machine, and they were not aware of what we were doing, and in any case, they didn't complain. And when we contact them, they say they were really thankful, you know. They were really kind to us. We say, great, thanks a lot. So positive feedback. It's true that if you are a company, probably you cannot run such tests. You cannot start scanning 650,000 IPs using Nmap. So maybe that's violate, you know, the privacy, the policy of a company. But until you don't break into system, until, you know, the machine we test are the machine that we rent explicitly for the experiment, and we pay for them. Mm-hmm. So we pay. So we rent machine A for us, only for us. We pay them. We pay this machine. We scan this machine, and then we close down. Then we take machine 2. So we didn't hurt nobody at the end of the day. Yeah.
Okay, are there any more questions for Marco? No. Okay, well, Marco, I want to thank you very much for your talk.
Yeah, thanks to you guys. I hope you enjoyed.